Hello guys, my name is Craig and welcome to Premier Solutions. In today's video, we're going to talk about intersecting lines under vectors. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So to start off, we shall look at three possible ways in which two lines can intersect, right, in two dimensions, right? So in two dimensions, there are three possibilities of line intersecting. So the first one is that they intersect at a point, at a common point, right? And then the second one is that either they are parallel to each other. In other words, they're in the same direction, but they don't have a common point. And then the last possibility is that they are coincident. In other words, they simply say it's just the same line, right? So we say two lines intersect at a common point, right? In this situation, right? When they've got a common point actually, right? And then we say two lines are parallel if they're in the same direction, but with no common point, right? And then we say two lines are coincident if they have an infinite number of common points, right? As you can see, right, that we might have actually 2 points, 2 lines within this one line, right? So basically, we're saying they've got an infinite number of common points and they're in the same direction. So this is in 2 dimensions. So in 3 dimensions, there is a fourth possibility that the lines are neither intersecting, parallel, nor coincident. So when two lines don't intersect and they're not parallel and they are not coincident, we say that they are skewed, right? So we say that this is now in 3D. So in 3D we say that they are what? They are skew. So skew meaning that they neither have a common point and they're definitely in opposite, different directions, right? They're in different directions and they don't have a common point. So this is in 3D, right? So this was what we had to look at under intersecting lines, right? Now let's attempt these questions. Shall we erase this? Right. So the first question says that in each case, determine whether the two lines intersect and find the coordinates of any points of intersection, right? So for a point of intersection, it means that this t and this lambda, they should have a value, right? Such that the position vector from each equation is the same, right? The position vector from this equation is the same as the position vector of this from this equation. So basically, we're going to solve for this t and the lambda. But basically, if we take a look at the direction vectors, those two are not related. So these are definitely not parallel lines, right? So now let's figure out if they're intersecting or they're skew lines, right? So we're saying that for the first equation, r is equal to 1 minus t, 2 plus 5t, and then 2t, right? Then for the second equation, r is equal to 2 plus 3 lambda, right? Then minus 1 minus 2 lambda, and 5 plus 6 lambda, right? So we've got this. Right. So we shall equate this to, because we need a common position vector. So we're saying 1 minus t, 2 plus 5t, then 2t is equal to 2 plus 3 lambda minus 1 minus 2 lambda and 5 plus 6 lambda. Right, then 1 minus t is equal to 2 plus 3 lambda and 2 plus 5t is equal to minus 1 minus 2 lambda. So now if we solve this being equation 1, then equation 2, and of course here we could solve for equation 3, 2t being equal to 5 plus 6 lambda. So this is equation 3. But from equation 1, we can say t is equal to 1 minus 2, that's minus 1 minus 3 lambda. Such that by substitution, we're saying 2 times minus 1 minus 3 lambda is equal to 5 plus 6 lambda. Right. And then, here we can expand. Minus 2 minus 6 lambda is equal to 5 plus 6 lambda. And then, minus 7 is equal to 12 lambda. Lambda is equal to minus 7 over 12. Then t would be minus 1 minus 3 times minus 7 over 12, which is minus 1 plus 4 over 7. Minus 1 plus 4 over 7. Minus 1, let me change this. Minus 1 plus 4 plus 7 over 4 actually. But that will be 3 over 4. So t is 3 over 4. So now if you make substitutions for these two should be equal if they have to intersect. If they're skew lines, this and this will be equal. So we're saying t minus 1 minus 3 over 4, that's a quarter. Then 2 plus 5 times a quarter, that's 18 over 4. Right, and then 2 times t, that's 3 over 2, right? So this is that. And then now for the lambda part, we say 2 plus 3 times minus 7 over 12. That will give us 1 over 4, right? And then minus 2, minus 1 minus 2 times minus 7 over 12. That will give us 1 over 6, right? And then 5 plus 6 times minus 7 over 12, that will give us 3 over 2. So as you can see, that we've got quarter, 3 over 2, 3 over 2, but 13 over 4 is not equal to, so 13 over 4 is not equal to 1 over 6. So these two lines, they don't intersect. Right, this line and this line, they don't intersect, which implies that these two are skew lines. When we say skew lines, they neither intersect, right, and they're neither parallel as well, right? So those are skew lines, right, for part A. And I'll leave you to try out part B. Right, part B is now just given in unit vector notation, but basically the working is just the same, right? The working is just the same. So now let's move on to look at number 2. Number 2 says find the position vectors, position vector of the common point for each of the following pairs of lines. So first part, we've got r being equal to 1, 1, 0. Plus t, which is 2 minus 1, 0, then r 2, 1, 0 plus lambda minus 1, 1, 0. Right. So to find the position vector of the common point is when this intersects with that. Right. So we are combining this to have 1 plus 2t, 1 minus t, and 0. Right, that being equal to this, which is 2 minus lambda, 1 plus lambda, and 0, like that. So we're now just equating, we're saying 1 plus 2t is equal to 2 minus lambda. This is equation 1, and then 1 minus t is equal to 1 plus lambda, which is equation 2. So if we solve by elimination, and we say equation 1 plus equation 2, here we get a 2, there we get a plus t, here we get a 3, and then there we get the lambda goes. It was minus lambda plus lambda gives us 0, such that t is simply equal to 1. Right? Then lambda will be equal to 1 minus 1, being 1 plus lambda. Then lambda is equal to minus 1. So t is equal to 1, lambda is equal to 1. T is equal to 1, lambda is equal to minus 1. Such that the common point, the position vector, we shall substitute for either of those, right? If we decide to substitute for this, it will be 1, then plus 2t, which is 1 plus 2, we get it 3. 1 minus 1, we get it 0, and 0. Right? So 3, 0, 0. If we decided to substitute for this to be 2 minus minus 1 to get 3, then 1 minus 1, 0, 0. So the position vector there is simply 3, 0, 0. Right? That's the position vector that we need. And now moving on to part B. Right, now moving on to number 2b. For number 2b, we've got that in what is it called? We've got this in unit vector notation. So if we combine this, we've got 2i plus 3si, which is simply 2 plus 3si, right? 2 plus 3si, right, 2 plus 3si, and then plus minus 1 plus sj, right, and then plus k, right, and this is being equal to this. So minus I plus 3 plus minus 3 lambda I, we are simply saying minus 1 minus 3 lambda I, then plus 1 plus 2 lambda j, right, and then plus k. So now if we equate the i's, we're saying 2 plus 3s is equal to minus 1 minus 3 lambda is equation 1. And then the j's, we're saying minus 1 plus s is equal to 1 plus 2 lambda is equation 2. So if we solve by substitution, here we see that s is equal to 2 plus 2 lambda, such that 2 plus 3 times 2 plus 2 lambda is equal to minus 1 minus 3 lambda. Right, then 2 plus 6 lambda is equal to minus 1 minus 3 lambda, and then 9 lambda is equal to 8 minus 8 minus 9, and lambda is equal to minus 1, which implies that s is equal to 2 minus 2, which gives us a 0. Right. So now for the position vector, we shall substitute for A of E. We substitute s being 0 here, we've got 2i, right, minus j, then plus k. So this is the position vector of the common point. Then now moving on to number 3. Number 3 says points P, Q, R, and S have coordinates 2, 0, 1, minus 1, 3, minus 1, minus 5, minus 1, 2, and 1, 4, 4, respectively. Right. Question says show that the lines PQ and RS are skew. Which means that these lines, they are not parallel, they don't intersect, they are in different directions, and they have no common point. Right? So, first of all, we shall find the line PQ, right, which implies that we need the vector PQ, right? And vector PQ shall be given by Q, point Q minus point Q, sorry, point Q minus point P. Right, so point Q minus point P, this is where is Q? QP. So we're saying minus 1 minus 2, that's minus 3, and then 3 minus 0, that's 0, and minus 1 minus 1, that's minus 2. So this is PQ, such that the equation R will be equal to position vector, we can take OP, which is 2, 0, 1, plus t direction vector minus 3, 3, then minus 2. Right, this is the line PQ, right? And then now line RS, we need vector RS is of O. Vector RS is given by S minus R, So 1 minus 5, that's a 6. And then 4 minus 1, that's a 5. Then 4 minus 2, that's a 2. Right? Such that the equation for line RS is given by position vector. We can take OR, which is minus 5 minus 1, 2, plus S, direction vector 6, 5, 6, 5, 2, like this. Then now we need to show that these are skewed. So if these are skewed, it means that for the values of T and S, the position vector of the common point is different, right? So we need to combine these two. Allow me to erase this part here. Right. So we're saying that 2 minus 3t, then 3t and 1 minus 2t, right, is equal to minus 5 plus 6s, then minus 1 plus 5s, and 2 plus 2s. Right, so 2 minus 3t is equal to minus 5 plus 6s, then this equation 1, then 3t is equal to minus 1 plus 5s, this equation 2, then 1 minus 2t is equal to 2 plus 2s. This is equation 3. So now we shall solve for t in s. So here if we calculate this by substitution, let's take equation 1 and 2. Here if we make 3t subject of the formula, we're saying 3t is equal to 2 plus 5, that's a 7 minus 6s. Such that this 3t is equal to that, then 7 minus 6s is equal to minus 1 plus 5s, such that 11s is equal to 7 plus 1, which is 8, then s is 8 over 11, such that t, we're saying that t is equal to 7 minus 6 times 8 over 11, all over 3. Right, 7 minus 48 over 11, then this over 3. Right, let's see what we get here. So 7 minus 48 over 11, then divided by 3, we get 29 over 33. So t is equal to 29 over 33. T is equal to 29 over 33. Right, such that if we now substitute right here for t and for s, for t first, we're saying 2 minus 3 times 29 over 33, right, we get minus 7, minus 7 over 11, right, and then 3t, 29 over 33, we get 3 times 29 over 33, right, we get 29 over 11, so rather write that here, 7 over 11, 29 over 11, and 1 minus 2 times 29 over 33, we get minus 25 over 33. Right. This should be equal to, when you substitute for s, so minus 5 plus 6 times 8 over 11, we get minus 7 over 11. Then minus 5, minus 1 plus 5 times 8 over 11, we get 29 over 11. Then 2 plus 2 times 8 over 11, we get 38 over 11. So we see that minus 25 over 33 is not equal to 38 over 11. So this is not equal to that, which implies that lines PQ and RS are skew. So this was simply looking at intersecting lines and your vectors. And please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.